Hello all, welcome to Inspirational STEM. So the question that we have today is find the domain and range of y equals minus 5x squared minus 10x plus 15. Okay, so I'm going to write my formulas on this side and theory. So formulas, and we're going to write the steps on the left. Steps. So step one. So the very first thing we want to see is y equals negative 5x squared minus 10x plus 15. So you want to see uh, if there is a greatest common factor. Okay, so find the GCF. So why are we finding the GCF? Is because we want x squared by itself. Okay, so we can complete the square. So why do we want to complete the square? Because remember, in order to find the domain, we need the parabola and its vertex form. Okay, so what is the vertex form of a parabola? If you recollect, it is a x minus h squared plus k, where h and k, the point hk, is the vertex of the parabola. So in order to do that, we have to have it in this completed square form. So in order to do that, we need x squared by itself. So let's go ahead and see what the greatest common factor is. It's in here. In this case, it's going to be negative 5. So I'm going to try to bring out a negative 5. So I have x squared plus 2x minus 3. So a quick way to check if this is correct is to just distribute back and see if you get the original equation, which is up here. So negative 5x squared negative minus 10x minus 5 times minus 3 is plus 15. So yes, we do indeed get back the original. So this is what we're going to factor out. Now we're going to work within this parenthesis. So let's go and write that. So step 2 is to complete the square. So complete the square. Okay, so if you remember, let's go and talk a little bit about completing the square. So remember that the if when you have something in this form, a squared, so let's just put an arrow here, a squared plus 2ab plus b squared. So this is the expanded form of it, and you can rewrite that in a square form, which is a plus b whole squared. So this is a perfect square trinomial when you get terms like this, and then you can write it as a plus b whole squared. This is what we're trying to complete in this case. Okay, all right, let's see how this will work. So let's have negative 5 again on the outside, and then I have x squared plus 2x. So I'm going to work with these first two terms. Okay, these two terms right here is what I'm going to work with. We'll come to that in a minute. So if you remember the how to complete the square, we have the b term in this case, ax squared. So ax squared plus bx plus c equals y. That's a quadratic equation. So this coefficient of the x, which is the b term, so what we're going to do is we're going to take that and we're going to divide it by 2 and square it. And in our case, what we have is we have 2 as the coefficient. So we're going to divide that by 2 and square it. So we are going to get 1 squared is equal to 1. So that's the term we are going to add and subtract in order to complete the square in this case. We have to remember we have to add and subtract both. Why? Because we just cannot add something and not subtract it. So I'm going to add a 1 and I'm also going to subtract a 1. Now see, in reality this would just cancel itself and we would be back to the original, but that's not what we're going to do. We basically want to be able to use these first three terms for a perfect square trinomial. So, and then we're going to write our negative 3 that's up here. So negative 3 and then finish the parentheses. Okay, so the very next thing that I'm going to do is Again, bring the negative 5 outside, and then I'm going to start up two parentheses in this case. So the inside parentheses is going to be my completed square. This is x squared plus 2x plus 1. So that's going to be x plus 1 whole squared. That's x plus 1 whole squared. So which is x squared plus 2x plus 1. And then negative 1 and negative 3 is going to be negative 4. Okay. So I'm gonna close this. All right. So step 3 is simply going to redistribute our negative 5. So distribute the whatever we took at GCF, and in this case what we are going to get is simply this is going to come over here. So it's going to be negative 5 x plus 1 whole squared plus 20. So negative 5 times negative 4 is going to give us positive 20. Okay, so we have come to the place where our equation is looking very much like the vertex form. Let's just go ahead and write the vertex form just below it, just to so you can see the comparison here. So ax minus h squared plus k. So remember, that's our vertex form. So let's compare what we have. Very clearly we can say right away that 20, so k equals 20. So that's very clear. The only thing that's a little confusing here is the fact that you have a plus negative in the formula, but there's a plus 1 here. So we can rewrite this if we want, right? Rewrite this as x minus 1. Okay, so, and of course there'll be a whole squared, but you see why we did that is because there's a negative in the formula. So I'm reintroducing the negative, and then there's got to be a negative 1 in order for this positive to happen. So which means my h term is going to be not positive 1 but negative 1, because when I put this in the formula, it becomes negative times negative is positive, so it becomes positive 1. So this is going to be my h term. Okay, so let's write down the h and k terms then. So we have h and k, which is basically the x value and the y value of our vertex is going to be negative 1 and 20. Okay, so just as a quick reminder, what is the vertex? So if you have a parabola that's opening upwards, for example, something like this, then the vertex is the lowest point. Oops, that did not. Okay, there we go. So that parabola right there. So this is the vertex. This is h and k. So let's draw another parabola which is opening downwards, for example this way. The vertex in this case happens to be over here. So that's our hk, the x coordinate, and the x and the y coordinate of the vertex. So that's what we're talking about here. All right, so we have then our vertex is negative 120. So let's just quickly, so step 4 is let's determine our domain and range. So domain, so if you remember again, domain and range, domain is the all the x values is the domain. So x values that are possible for this equation, and then range is all the y values that are possible. Okay, so let's look at what we have. We have negative 120. So let's just quickly try to draw a rough sketch here. So let's say we start like here, and so we have negative 1, x is negative 1, so negative 1 is up around here, and let's just pretend 20 is up here, so 20, and then so this is the point of the vertex. And remember, if you look at the parabola, it's negative 5 coefficient of the x squared, which is basically, it means it's a downward opening parabola. So downward opening parabolas have this a term over here, or the ax squared plus bx plus c. This is a term, this coefficient is negative, okay, and this one, the a term is going to be positive. All right, Okay, so that means this parabola is going to open downwards this way. So let's say this parabola is going like this, and this parabola opens downwards like that. So, and then it's going to keep continue going in this direction and this direction. So the idea is that as this parabola keeps becoming bigger and bigger and keeps going further and further, it's going to basically take into account all of the x values, which are the x values. It's going to take into account all the x values. So there are literally no restrictions on the x values that possible. As the parabola becomes bigger and bigger and bigger, you're going to incorporate all the x values. So we can say that our domain is basically all real numbers, which is also represented by this r with a double line. So that's all real numbers. Okay, also another way to represent that is in parentheses negative infinity to positive infinity. So that's the x with all real numbers. So look at the range now. Range, of course, is the y values. As you can see here, the y values start from 20 and then they go this direction towards the origin and then further from there. So the range can then be given as, so we can write it as y is not going to be greater, because the greater would be more than 20. It's going to be less than 20, less than or equal to 20. So why is it less than equal to? Because it's going to start at 20 and then it's going to start going, all of the y values are basically going to be can become smaller and smaller and go all the way to negative infinity. Okay, so another way to write this in parentheses would be, you got to start with a bracket, because that includes the 20. As you see, this is a solid line here, so it's going to include the 20, and then you're going to write a comma, and then you're going to write negative infinity. Okay, and then finish with the parentheses. Remember, always when we write with the infinities, we don't know what the infinity exactly is. It's just a very, very, very big negative or positive number. So we are just going to say that it's a parenthesis because we don't exactly have information of what that is going to be. But in this case, we know for sure it starts at 20 and it includes that point 20. So that's why we put this bracket. Okay, all right. So then this is our final answer. Our domain and range is given by all real numbers for the domain, and for the range it's going to be y is less than equal to 20, and that's what we received from the vertex formula after completing the square. All right, so I don't know if you have any questions. I would be happy to answer them. If you could please leave a comment below this video, I'd be happy to answer any questions that you have. And also thank you for watching the video. I would really appreciate it if you like and subscribe to this channel. Also, please let us know in the comments below what kind of videos you would like to see, and if you have any particular problems in math or the different branches of science like physics, chemistry, and biology, I'd be happy to make a video on those topics. All right, well, thank you for watching and have a wonderful day, and I'll talk to you in the next video. Okay, bye.